this section, we are learning about constructing confidence intervals for a population proportion. So we are trying to estimate P, our parameter, given P hat. So that's what we're going to have. I also want to remind you from earlier in this chapter that the way we construct a confidence interval, which is given as an interval of plausible values, we have a lower bound and an upper bound, and we're saying we're C% confident that the true, in this case, population proportion is going to be within this interval of values. And the way we calculate that is we take our point estimate, which is our statistic, plus or minus our margin of error. Now, a margin of error has two parts, a critical value and a standard deviation. And today, since we're talking about proportions, our point estimate is going to be P hat. Our critical value, we'll talk about that here in just a second, but we call that Z star. And then our standard deviation should look very familiar. It's our standard deviation of the sampling distribution of P hat from back in chapter 7. And that's just P, 1 minus P divided by N. But I don't have P, so I actually am going to use my P hat instead because we're trying to estimate population proportion P. We don't actually have that. And so the first thing we're going to learn to do is how to find this Z star, which I know is a new term. So this is a new skill for us. So the way that we're going to find this Z star value, and we're going to sort of ignore this for a moment. I'm going to draw you a picture because I think it makes a little more sense that way. Remember from chapter 2, we learned about normal curve. And our Z star is actually going to be a bound on the normal curve where we're given area, our confidence. So if I'm going to use this as an example, our 90% confidence. And I know here it's keeping it in percent, but because we learned about a density curve, the area under it is 1. I'm going to say if my confidence is 90%, that area is going to be 0.9. So this is representing my confidence level. So I'm going to put 0.9 right here. Now, in order to get a bound when I'm given area, because that's what we were just given, area under the curve, and I want this value here. And do notice we have these standard scores, which means this is from a standard normal curve, meaning my mean is 0 and my standard deviation is 1. You are going to get a negative value because remember our Z-score is negative if it's below the mean. So our mean would be in the center at 0. And so the Z-star that we're going to get is actually going to be a negative number. No big deal. So we're just going to ignore the sign because the sign doesn't actually matter because we're going to add it and subtract it anyway. We're going to do both of those things, subtract to get the lower value and add to get the upper value. Okay, so I don't want this area though. I need the area to the left because if you'll recall, in order to get a bound, which I'm going to call Z star, back then we usually called it X, we're going to use the function in the calculator called inverse norm. And the calculator is going to ask you for two parts. It's going to ask you for area to the left, mean and standard deviation. Now, our mean and standard deviation are 0 and 1, so you actually don't have to enter anything in. Your calculator will assume that, but you really do have to calculate this part, this area to the left. So the way that we're going to do that is we know that this adds up to 1, so I'm going to go 1 minus my C, my 0.9, and I get 0.1. But 0.1 would be both of these areas, and I only want one of them. The normal curve is symmetric, so if I only want this left tail, this area here, I can simply divide by 2, and I get 0.05. So that is the area that I'm going to put in my calculator. So, and also recall to get to inverse norm, what you're going to do is you're going to go to your distributions. So second bars. So we're going to go second bars, inverse norm. Again, it asks you for area, but it does mean area to the left. You're going to enter in 0.05. Your mean is 0 and your standard deviation is 1. And I get 1.64. Now, we're usually going to round to the 100th. That's where we typically round to for a critical value. Notice to the right is a 4, so I'm going to round down to 1.64. So let's now look at these directions, but this is why this works. So this is what we're doing here. Now, I don't like to keep it in percent. I normally immediately turn my confidence level of 90%. Go ahead and turn that into a decimal of 0.9. So we're going to go like this. We're going to go 1 minus C, and then we're going to divide by 2. And then I don't even have to worry about this part. I already did that. I'm just going 1 minus C, divide by 2. And then in my calculator, there it is, go to second vars, inverse norm, and then you're putting that answer from above. Drop the negative. You don't have to worry about that. So it's just 1 minus C divided by 2. And again, I would just recommend never keeping your C as a percent. Just always go ahead and convert that thing to a decimal. All right. So I already did this one with you, but I'll write out how we found it. So we knew that Z star, it was equal to inverse norm. And then our area to the left was 1 minus C, 0.9 divided by 2, which was 0.05. That's what I typed in. So let's do it again for 95%. So this time my C is 0.95. So I'm going to go Z star equals inverse norm. And this time it's going to be 1 minus C, 1 minus 0.95 divided by 2, which is 0.05 divided by 2, which is 0.025. Again, you don't actually even have to enter in that 0 and 1. Your calculator will assume that. So you can, it doesn't hurt anything, but it's going to assume that your mean and standard deviation are 0 and 1. So now I take out my calculator. I'm going to go second vars, inverse norm, and I'm going to type in 0.025, which is 1.96. Let's do it again for 99% confidence. So I know that Z star equals inverse norm, and I'm going to find that area to the left. So to find that area to the left, I go 1 minus C, which is 0.99, and I divide that by 2. 1 minus 0.99 is 0.01. When I divide that by 2, I get 0.005. Again, I'm going to go to second vars, inverse norm. We're going to go 0.005. And there we have 2.5. Now notice the thousandth place is a 5, so I'm going to round this up to an 8. All right, I'm going to stop here for just a moment to reinforce something that we learned in the earlier section. So we learned in 8.1, we learned that as confidence level goes up, this is what we learned. We learned as C increases, we learned that our critical value, you didn't know what it was yet though. We said as C increases, critical value increases. And I want you to notice that this is happening. Watch this. When C equals 0.9, my Z star was 1.64. C is going to go up. Now it's 95%. Look what happened to my Z star. It got bigger. All right, so my confidence level's increasing. Look what happened to my Z star. It also increased. And I want you to consider your margin of error. Remember that your margin of error has 2 parts, a critical value and your standard deviation. So if either one of these things increases, the product must increase. So if confidence level goes up, then your Z star gets bigger. And if Z star gets bigger, your entire margin of error must get larger as well, right? Because one of your factors is getting bigger. And if our margin of error gets bigger, we found that our whole interval got wider. Which this holds true if C goes down as well. So if you decrease your confidence level, if you make C get smaller, so I had a 99% confidence interval. If I were asked a question like, I had a 99% confidence interval and I decide to make a 90% confidence interval, what's going to happen to the width of my interval? Well, let's think that through. If our confidence level gets lower, well, then my Z star is also going to get lower, which means my whole margin of error is going to get smaller, which means my interval is going to get narrower. All right. It just makes more sense once we've seen this piece. We said that back in 8.1. We were like, okay, well, if C goes up, critical value goes up, but you didn't even know what critical value was. So I just wanted to take this opportunity to show you, here's how you calculate critical value and notice what's happening. As our C increases, our Z star is indeed increasing. Okay, so now let's go ahead and calculate an entire confidence interval. Okay. We are given a point estimate of 0.45 and a confidence level of 92% and a sample size of 50. So our first step, because we have p hat plus or minus z star times standard deviation, which is this big, beautiful thing, p1 minus p divided by n. There we go. And so our p hat, they just told it to us. Our p hat is 0.45. So in a minute when we calculate this thing, I wish I had more space on here. I'm going to come over here. So now we have our p hat is 0.45. And we're going to calculate our z star. And then we're going to calculate our standard deviation so that we can find our margin of error. So we have find the z star. Okay, well, we know how to do this. We're going to go z star equals inverse norm. And we have to find the area to the left. Well, my confidence level is 92%, or C equals 0.92. So we're going to go 1 minus 0.92 divided by 2, which is 0.08 divided by 2, which is 0.04. So that's what I'm going to type into my calculator to get my Z star. So I'm going to go second bars, inverse norm, 0.02. I meant 4, 0.04, right? 0.04. Sorry about that. And I got 1.75. Remember, I ignore that negative symbol. So we're going to go 1.75. So this is my Z star. So I have my Z star. I can plug it in. 1.75. Now I'm going to find my standard deviation. So my standard deviation of the sampling distribution of p hat, which since we don't really have p, that's really called the standard error. We kind of go back and forth. Our notes call it standard deviation. Our textbook calls it standard error. Again, the reason for that is simply that we have a statistic instead of a parameter to use in our formula. So I just don't want you to be confused later if you see these interchanged. No big deal. It's the same thing, but we're using this formula. We're going to go, our p hat, they told us is 0.45. 1 minus 0.45 is 0.55, and our sample size they gave us is 50. So I'm going to type that in my calculator. Don't forget to take the square root. So I'm going to go square root, and I have 0.45 times 0.55 divided by 50. And I get 0.07. And I'm actually going to keep to the thousandth place, 0. So here we go. So now I have my standard deviation, 0.070. Now, when they ask us to find the margin of error, I just want to remind you that our margin of error is simply our critical value, Z star, and our standard deviation, which is P, 1 minus P over N. It's really P hats, though. So we have those values. So our Z star is 1.75. Our standard deviation is 0.070. I actually am not going to use a rounded value because intermediate rounding is not good. So even though I wrote 0.070, I'm going to scroll up. And I go times. I'm going to scroll up and grab that guy. So there's my standard deviation equals. Okay, there we go. So, which I got about 0.123 for my margin of error. Construct the confidence interval. So remember, our confidence interval is just point estimate plus or minus our margin of error. Well, our point estimate is 0.45. Our margin of error is 0.123. So my confidence interval is going to look like this. To get the lower value, I'm going to go 0.45 minus 0.123. 0.45 minus, and I'm just going to scroll up and grab it, 0.123, which gives us 0.327. And then to get this upper value, I take my point estimate and I add 0.123. I'm actually going to go up, check this out. So you can go up and grab, and I'm just going to change this to a plus. Plus. There we are. And I get 0.573. And there is my confidence interval. Now I'm asked to interpret the interval in words. So our interpretation always goes like this. We are, whatever percent confidence level, C percent confident, 92%. So, and this is where in our earlier notes we say we are C percent, and in our case it's 92%. We are C percent confident that the true, and normally we would say parameter, but what is our parameter? It's a population proportion. Normally that would be in context. This particular example has no context. So we'll just say that the true population proportion, because that's what this is, a proportion, p hat, is between, this would normally be in context, whatever that population proportion we're talking about is between, and we just give our interval, 0.327 and 0.573. That's my interpretation. All right, let's do one more. Find the confidence interval given. So this time we have p hat is 0.23, and our confidence level is, I like to write that as a decimal, 0.97, and we have our sample size is 100. So to find our z star, we're going to go inverse norm, and we have to find the area to the left, which means 1 minus my c, 0.97, divided by 2, which is 0.03 divided by 2, which is 0.015. And I'll type that in. So we're going to second bars, inverse norm. This time I'm putting in 0.015, and I got 2.17. So my z star equals 2.17. Okay. Next step, calculate the standard deviation, which you may also see referred to as a standard error. That won't make us upset. No big deal. So my standard deviation of the sampling distribution of p hat is going to be p, we have p hat though, 0.23, times 1 minus p hat, 0.77, divided by n, which ours is 100. So I'm going to calculate that guy. All right, so we have 0.23 times 0.77 divided by 100, and I get 0.042. All right, so there's my standard deviation. And then it says find the margin of error. So now remember, my margin of error is just my critical value times my standard deviation. So that's going to be, my critical value is 2.17. My standard deviation is 0.042. 2.17, and I just like to go up and grab it. There we go. And I get 0.091. 0.091 is my margin of error. Okay, so now I'm ready to construct that interval. So again, I want to remind you that to construct an interval, I take my p hat and I do plus or minus my margin of error. So my p hat is 0.23, plus or minus my margin of error is 0.091. So when I construct that confidence interval to get this low value, I'm going to go 0.23 minus 0.091. So 0.23 minus this guy. And I get 0.139. And then I'm going to do the same thing, but this time I'm going to add, right? 0.23 plus 0.091. And I get 0.321. Now I'm ready to interpret. So we would say we are C percent, 97%. We are 97% confident that the true population proportion, though usually we would have some kind of context in the problem. Population proportion is between 0.139 and 0.321. And that is all for this note section.